When two galaxies collide, the black holes at their centers merge, triggering ripples throughout spacetime. These gravitational waves were predicted by Einstein over 100 years ago and were detected for the first time earlier this year. Now new research shows gravitational waves are produced 10 million years after two galaxies merge, which is much faster than scientists had expected. The discovery may mean we might be able to detect more than previous estimates. This could help us understand how the universe evolved and to further test Einstein's theory of general relativity. When Einstein published his theory of general relativity in 1915, it was predicted gravitational waves would form from the merging of black holes or neutron stars. But the point at which gravitational waves are triggered and spread throughout space was not known. Now an international team of astrophysicists from the University of Zurich, the Institute of Space Technology Islamabad, the University of Heidelberg and the Chinese Academy of Sciences has now calculated this for the first time using computer simulations. Every galaxy has a supermassive black hole at its core, millions or billions times the mass of the Sun. The researchers created a realistic simulation of the universe, in which two 3-billion-year-old neighboring galaxies merged. With the aid of supercomputers, the researchers calculated the time the two central black holes with around 100 million solar masses needed to emit strong gravitational waves after the galaxies collided. The result is surprising, said Dr. Lucia Mayer from the Institute for Computational Science at the University of Zurich. The merging of the two black holes already triggered the first gravitational waves after 10 million years, around 100 times faster than previously assumed. The computer simulation, which took longer than a year, was conducted in China, Zurich and Heidelberg. The model was more detailed than previous attempts because it factored in the relation between the orbits of the black holes and the structure of the galaxies. Our calculations therefore allow a robust forecast for the merging rate of supermassive black holes in the early stage of the universe, Dr. Mayer said. They may help assess the gravitational waves ELISA is bound to find in the near future more effectively. A new space-based gravitational wave detector known as ELISA, funded by the European Space Agency and due for launch in 2034, will be powerful enough to detect more gravitational waves. In 2015, ESA launched ELISA Pathfinder, which is successfully testing several technologies which could be used to measure gravitational waves from space. The researchers found that the ELISA detector will be particularly well suited to detecting black hole kicks. They say it will be capable of measuring kicks as small as 311 miles per second. Kick measurements will also tell us more about the properties of black hole spins, and also provide a direct way of measuring the momentum carried by gravitational waves, which may lead to new opportunities for testing general relativity.